So hello everyone, is my voice audible?
Yes, sir.
Yes, sir.
So let us first solve the assignment for week 12 for the previous year, and then we will discuss some problems, extra problems. So the first problem of week 12, it is said that the CFO in OFDM system. So it has been discussed in the previous sessions, like CFO does not change the SNR, but what it does just add some part of the another signal to the actual signal. So it remains the SNR constant, but the interference plus noise ratio, that is SINR, that thing is getting affected. So that is the reason the correct option is option D for question number 1. There are 4 options. First option decreases signal to noise ratio and keeps signal to interference plus noise ratio constant and all these things, and it has been discussed in the previous class. So first is option D. The next question here is, this is also has been discussed. So I am just discussing the things that has not been discussed till now. So the first thing, for a multi-user, the question number 4, for a multi-user my millimeter wave communication, the CFO is, so if we think for a multi-user millimeter wave communication, that is the scenario for this type of scenario. Let us take, you have one particular transmitter, this is from a box, and it has 2 antennas, and suppose it is the base station, and you have one user here, one user here, and one user here. So this is what the multi-user scenario. So the previous case, we had one antenna side here and the boxes were attached like this, but and there was one receiver and it had MIMO system. So this is only MIMO system. If it comes to multi-user, so each of them has 2 different antennas. So I say it is base station, this is the receiver 1 or user 1, receiver 2 and receiver 3. In the sense I will say user 3, this is user 2 and this is user 1. So each of them has a different antenna, and that is the reason the CFO at each of them will be different, like in the spatial domain. That was not in the case for MIMO system. So let us go back to the question. So the right option is option C, because it is different because of isolated and independent receiver side. So what is isolated? They are not connected in between and they are independent. They has no dependency on this, like they are not that close that the channel is also, like the receiver has some characteristic that they match from the same clock type of thing. So that is the reason the CFO will be defined for each of them. So that is the reason the correct option will be option C. So question number 4, it has option C. And question number 3 was discussed earlier, like CFO is not added in. So CFO is a thing that adds up in the time domain, not in the spatial domain for a MIMO system. So the right option will be option C for question number 3. It has been discussed in the earlier classes. So let us go to the question number 5. So question number 5 says the error due to hardware impairment is linear additive, option B is nonlinear and multiplicative, option C is both A and B, and option D is only nonlinear and additive. So this hardware impairment noise comes from the silicon process and all these things, and it is not only the thermal noise, it can be any impairment like power amplifier impairment or silicon process impairment, all these things. So this error we cannot conclude like the thermal noise is additive and Gaussian in nature, but the errors due to the power amplifier is somehow non-linear in nature. You can think like it amplifies after a certain region, it just saturates all the gains, that type of thing you can think of. So that is the reason it can be linear, it can be additive if it is if we consider only the thermal noise, and if we consider that it comes from the power amplifier side, so that is in that case it is non-linear and multiplicative also in some sense from the non-linear nature, or some impairment in the RF decoder or anything, like it can come a multiplicative noise, that is due to the because this noise is because hardware impairment noise. So the right option will be option C. So question number 5 has option C, and it is both A and B. So let us go to the question number 6. Question number 6 says the hardware impairment noise depends on frequency, silicon process, temperature and silicon process, and all of the above. There are 4 options. So obviously it depends on the frequency. For different frequency, the noise due to hardware impairment can be different, and it also depends on the silicon process, and it also depends on what is the temperature of that particular system at that moment. Like this thermal noise also depends on temperature and all these things. So it should be, the option will be all of the above, like it depends on frequency, silicon process, temperature and the silicon process, all of this. So the option is option D for question number 6. So let us go to the question number 7 here. It says the effective noise in millimeter wave communication from transmitter side depends on. So the noise in the transmitter side, you can think there are from component wise. So thermal noise, it is the noise that if you propagate some signal through some electronic device, so there will be always a thermal noise. And also whenever you are getting some analog signal and you are just processing into the digital domain, there will be quantization error. And power amplifier noise, it is like suppose there are nonlinearity natures, because power amplifier is in the RF domain, and in RF domain there are this noise we cannot control, they are very much costly, and like this power amplifier noise is inevitable because you have to transmit the signal through the power amplifier, and some sort of distortion will be added that we can count as the noise. So in the transmitter side it should be thermal noise, it is quantization noise and power amplifier noise, all of the above. So question number 7 is also all of the above, and the option is option D for question number 7. Sorry, it is said that the data is independent on noise. So see, quantization error, it dependent on it is dependent, like you do some quantization and it depends on what data you are feeding into the system. So from that the quantization error comes. so it is not independent of data. And power amplifier noise is also not, you cannot think like, for power amplifier has certain characteristics over some sort of frequency it behaves linear, and after that it behaves non-linear. So but thermal noise, this thermal noise we don't have any control over, like you send some signal and it completely depends on the electrons collision and their movement. So the question is, which of the following is data independent noise? So this thermal noise is completely data independent, it has nothing to do with the data. Like you add, you send some data and there will be a thermal noise plus W that we say, and it has some variance. So that is the reason this thermal noise is data independent. So the right option for question number 7 is A. So let us go to the question number 8. Question number 8 says, the effective noise in millimeter wave communication from transmitter side depends on. So if I say the effective noise in millimeter wave communication from transmitter side depends on, it depends on thermal noise as I discussed earlier, and power amplifier noise it also depends, and RF precorder and baseband precorder. There are components as RF precorder and baseband precorder. Baseband precorder uses to get the advantage of MIMO system in millimeter wave, because we do not do the MIMO system in the wireless channel there, actually we do the beamforming there. So we have to do some sort of mixing kind of thing that happens in the MIMO system to get the advantage of diversity factors. So that can be done by this baseband precorder, and RF precorder is also used for beamforming and all these techniques. But all these techniques cannot be error free. Like you design some RF precorder and baseband precorder, there will be some error, you cannot get the exact value of them, and also it depends on the components like electronics components, so they will generate some sort of error. So thermal noise will be there. Power amplifier noise, it depends on the frequency and nonlinearity of the power amplifier, depends on the at what frequency you are transmitting the data. And RF precorder and baseband precorder, there will be some sort of mismatching between the ideal thing and I will say between the actual ideal thing we need and what is not. So the correct option for question number 8 will be option D, which is all of the above. So it has thermal noise, it has power amplifier noise, and RF precorder and baseband precorder. So it is all of the above, question number 8. Question number 8, option D. So let us go to the question number 9. So this is a straightforward question. The noise generated due to the power amplifier in transmitter side. So obviously it depends on what frequency we are operating, on that thing the power amplifier works. So this is data dependent at least, but it has non-linear nature. So the correct option will be option C. It is non-linear and multiplicative sort of thing. It's not like additive. So it is data dependent and non-linear and multiplicative. And the last question, what is the unit of channel capacity for unit bandwidth? So channel capacity of unit bandwidth, this question has also been answered in previous some lecture. So this is the unit of data rate, bits per second, and the question is asked is what is the unit of channel capacity, that is sort of data rate, for unit bandwidth. So if we write that like this, so per hertz, so this is the channel capacity, like how much data that can be sent over unit bandwidth. That is the channel capacity here. So right option is option 3. So let us discuss some problems here, like this may help you in the final exam probably, but I cannot assure. So this should be a interactive session, so you guys are expected to answer the questions. So let us demonstrate the question first. This says I have a WebDM system. So first thing, it has said that the coherence time is 0.5 millisecond and the bandwidth here is 20 megahertz, and the symbol duration, that is 0.1 microsecond. Okay, this 3 information has been given to you. Now my question is, what should be the N for this WebDM system? Like N is in the form of 2 to the power n, we know, because we need to do the FFT here. So that is number of subcarriers, you can say. So within one WebDM symbol, question is within one WebDM symbol, how many subcarriers, that is N, can be allocated. The information is given. This is the coherence time, this is the bandwidth for the system, and this is the symbol duration. So anyone to answer this question? So what we know, we have to allocate n into, okay, anyone to answer? Someone has mic is on, I think.
Is it T coherence by T symbol, sir?
Yes, and what is the answer? What should be the n? So, okay. So the first thing I will say, this is n into ts. Suppose, let me clarify it. So I have said number of subcarriers is n and the symbol duration is ts, and within this I have some also cp k. Okay, suppose cp is very fractional number with respect to this n. Like if I will not try to use more cp, because if I use more cp that will take my subcarriers. So the thing is, I can take n into particular symbol duration, and within this OFDM should not be changed. Like this, within it should be within the coherence time. So this should be at least the condition. TC should be greater than this NTS. So from this, if I take the equality constant, like it is the upper bound type of thing, so at least, but within this TC it should not change. So what should be n? N should be TC by TS. So this is 0.5 microsecond by, sorry, millisecond, sorry, by 0.1 microsecond. So this comes 5000, right? So my question is, n is 5000, right? Is it 5000?
It should be in the order of 2 power n.
Yeah.
So the nearest term, I think it is 4096. So you have to write what is the nearest term in order of 2 to the power n for this n. So the right n here is 4096. So let us extend this question. So I said now I have n is equal to 4096 from the previous question, and also I have the following condition: Tc is equal to 0.5 millisecond, Ts symbol duration, this is 0.1 microsecond, and B is 20 megahertz. These are the informations given to me. So now I want to know what is delta F, that is how much bandwidth I can allocate per subcarrier. This is the question. So I will expect answers from you. What is delta F?
It's bandwidth by n.
Bandwidth by n.
N.
Yes. delta f should be 20 by 4096, and it is, let us take it is 5 kilohertz. Like this 96, it is nearly comes as 5 kilohertz. So that is a catch right now. So suppose you have this symbol duration in the frequency domain. So you have this FDM within this band, and what happens if I use this whole 20 megahertz? This will have some sort of tails, and if it has some this sort of tails, it will create interference. With the next one, so that is the thing what we do exactly, like with the next one. So what we do, like instead of using the whole band, we just use a part of this, just truncate it within this. So what is the main thing here? We don't use all of the 4096 cap carriers, we don't use all the 4096 sub carriers. Instead we can use 3000, and this is a limitation, like you cannot use 20% of all of your sub carriers. This is a rule there. So suppose we can use 3000. Okay, so if we use 3000 right now, that happens what? So within this duration, what it does, this is the 20 megahertz, but suppose we use from here to here only. So now so what is the effective bandwidth now? We are using 3000 and 5 kilohertz. So this becomes 15 megahertz. And what was our allocated bandwidth? That was 20 megahertz. So how much bandwidth we are losing to avoid the interference? This is 5 megahertz. So this problem arrives in OFDM system. Now let us say what should be the ways so that I can utilize the full spectrum. So the first way, we can decrease TS by the factor of 2, that is symbol duration. So if I decrease TS by the factor of 2, my question is, what should be the delta F, keeping n constant, like 3000. Let us first discuss. So suppose n is 3000, we are not using all of them. So what should be my delta F such that the signal fits within 20 megahertz? I just need a numerical value at least in this case. Like n is 3020 megahertz, my total bandwidth is, and my symbol duration is decreased by 2. Like symbol duration was 1 microsecond at the beginning, now it has been decreased by a factor of 2. And what is the factor by, at least by what should be the delta f right now to allocate at least this 3000? Subcarrier.
Del F has to be increased.
Which should be increased? Bandwidth. But my there is a constant, like their bandwidth allocation occurs, so I cannot go beyond 20 megahertz.
This bandwidth is constant.
So bandwidth is constant, so what we can change is this delta f. If we think we have to adjust, so what should be the delta f right now? It should be
Bandwidth by 20 volts by
3000 for this case. Like we are using this 3000, but what we discussed earlier, interference may occur here, but still this is the rule, we cannot use the 20% of the total subcarrier. So this is 6.6 kilohertz. This is what. So what's the conclusion? If we decrease the symbol duration, it sum and keeps everything constant, it increases the delta f. So if we think for the whole system, if we had used this 4906, so as when symbol duration has been decreased by factor of 2, this should be increased by factor of 2. So if Ts is 0.1 microsecond, what was delta f for us? 5 kilohertz for the previous question. Now we said that it is 0.05 microsecond, so it would have given me 10 kilohertz. If we had given the relaxation of the bandwidth B, like bandwidth can change, at that case bandwidth could be 4.
Sir, delta f is equals to 1 by Ts, no sir?
Delta f is equal
That
to 1 by
is
T.
not.
No, this delta f is the bandwidth allocated per each subcarrier, and Ts is the symbol duration for the WebDM. These two are different. One WebDM symbol can contain n number of subcarriers, right?
Okay.
And each of the subcarrier has delta f here. Each of the subcarrier, like you are sending each for each subcarrier, you are allocating some sort of bandwidth. That is delta f. Okay. And now let us move the question in somehow, suppose we want that delta f should remain constant. Okay, this should remain constant. So if it is the scenario here, and bandwidth is also sort of constant. And what we discussed earlier, it is 0.1 microsecond. Now I decrease this Ts by a factor of 2 by 2, and it becomes 0.05 microsecond. Okay. So my question is, if I remain this delta f constant, for this first case n was 40, So if I remains all these things constant, what should be the new n?
This is bandwidth by del f.
Okay, so
So both are constant.
so n should be constant for you, like 4096 it will be for this case also.
N is independent of Ts.
Yes, n is independent of Ts,
So it remains the same.
but n is something Tc by Ts. So this is the mother equation for this thing. Here Ts is divided by 2. So symbol duration decreases here. Now think what happens.
थोड़ी देर 8 बजे तक.
If Ts decreases and Tc remains constant, N increases.
And if I say in this scenario it increases, that is right. If you can think like that. So actually what happens, your symbol duration it becomes 0.05 microsecond from 0.1 microsecond. So now as it Ts decreases, your n should increase by a factor of 2. So I think these 3 problems has no confusion till now, or any confusion from you guys, like these 3 problems I have solved till now. Like this sort of problem may come in the exam.
So you have taken that 3000. So you were saying we are left in 20%. So if we take a 4096 20%, that is something different, no?
Okay, like I just said,
So that's
like
the approx value or just example?
At least 20% you have to remove. Then I think this is 800 or something for 20%. Okay, so for my it is just I have taken 3000. At least it should be less than equal to 20%. That is the concept.
So we can take any value, no?
That will be given in the.
That is not fixed.
That is like
So,
for normal 5G or 4G system, what happens, like it is like you should not create interference for someone else, like someone also is transmitting some WebDM symbol, but you have bought the 20 megahertz spectrum. Okay, but someone else has bought the next spectrum, but as you have this whole band 20 megahertz, there will be interference for other guys. If you spend the whole band, like you cannot use the sharp filtering, so there will be interference. So that is the safety that has been mentioned by government or some political body. They will say that you cannot use the whole band, at least you have to leave some at least 20% of it, so that you should not create interference for your nearest neighbor. Is it clear? So from there the sharp cutoff fails like this.
Okay, sir. Thank you, sir.
Sir, here interference is also reduced. At the same time, the bandwidth is also effectively utilized. Can we say like
Bandwidth is not, you say that bandwidth is not effectively utilized, but even if I do that sort of thing, like what can I do? I can decrease the symbol duration. If I decrease the symbol duration, so at that moment we use 2096, 2048 or some 96 or some factor comes there, 48 probably 2048 subcarrier I can use in some cases. So what is your question? How can I use the bandwidth effectively?
yes, sir.
So in this case I have no option to use the bandwidth effectively, like I am not wasting my bandwidth. It is my constraint that it says you cannot use all the bandwidth, it is 20%.
Okay. Okay.
For that purpose, sir, I think we use other waveform technology, filter bank multi-carrier, FBMC, I think, no? That give better spectral efficiency.
If you use all these things, I think after all these things they have considered, for that you will still have some sort of interference, right? You never can design a sharp cutoff filter. A sharp cutoff filter is never realizable, right? So there will be some sort of sidebands there. If I use the whole band, there will definitely be some sort of sidebands there.
So one more question, sir. So, what is the maximum subcarriers that can be allocated within one OFDM symbol, sir? Is there any limitation?
It depends of how much bandwidth you can buy, like that relationship, that is n into delta f is equal to b.
ओके आ रही हूँ मैं नीचे
This delta f, it should
गेट पे ट्रिपल आईटी बैंगलोर गेट पे है ना गेट 10 इन्फोसिस आ रही हूँ तब
hello. Is okay. So this delta f should be such that your subcarrier meets the data you need to carry. Like each subcarrier is carrying some sort of data. So at least that part of information this should be given. Like each delta f is carrying some QPSK information or some BPSK information, and this is the bandwidth you have bought, B. Depending on these two, you can set your N. If you can buy a large bandwidth, you need more money. So if you have a big money, you can use big N. And also there should be that sort of device like 2 to the power n factor that can process that much data, this n factor.
Okay, sir. Okay, sir. Got it, sir. Thank you.
Okay. So anybody else has any question more? Okay, so that is all for today. Best of luck for your exam.
Sir,
Yes.
sir, in assignment 10,
in assignment and one question key was given wrong
Okay.
for an assignment.
Which
And in
assignment?
assignment 8,
Sorry?
assignment 10 and assignment 8. And key is not yet released for many assignments.
Okay, I will try to raise the concern there. Like it is not in my hand actually. Like
Actually, we are posting in like many of them posted in this forum, but there no response. So can you just pass the information to the PS?
okay, I will try for this case. I will try.
Yes,
Think,
sir.
sir, so far a single question is not answered in forum by the team members.
Th- that is something that is not in my hand actually. So at least I can try to raise the thing, but I have mailed them, but probably there is no answer till now. So I'll try my best to raise the concern, but I cannot guarantee you that what happens in the next. For this
So actually,
case,
when you say exam, sir, when you say exam plan, sir,
see, this kind of information you cannot get from me actually. I am not a course TA. You can ask me the question related to the coursework that I can answer, but exactly when the what question is going to come, or which type of questions, like these questions I got some pattern, like I have requested them and they send me these sort of questions. So that is why I discussed all these things, but probably this depends on the actual professor. So I cannot answer that questions, like you are, that is my limitation, you can say. Is it okay?
okay, sir. Thank you, sir.
Okay, best of luck for your exam.
Thank you, sir.